Hello grade 7 students, welcome to our virtual class for the third quarter, week 7. I'm Abigail Sarmiento, your science teacher. Our lesson for today is about electricity. In Module 5, you learn about heat as a form of energy that can be transferred through conduction, convection, and radiation. You identify the conditions that are necessary for these processes to occur and perform activities that allowed you to investigate the different modes of heat transfer. Now you will learn about another form of energy which you encounter in everyday life, which is electricity. You must be familiar with this energy since it is the energy required to operate appliances, gadgets, and machines, to name a few. Aside from these man-made devices, the ever-present nature of electricity is demonstrated by lightning and the motion of living organisms, which is made possible by electrical signals sent between cells. However, in spite of the familiar existence of electricity, many people do not know that it actually originates from the motion of charges. In this module, you are expected to describe the different types of charging processes. Most objects are electrically neutral. This means that they have an equal positive and negative charge, each cancelling the other out. In order to charge an object, you have to alter the balance of negative and positive one way or the other. There are three ways to do this. Methods. There are three ways to charge an object: friction, conduction, and induction. Friction involves rubbing on material with another, resulting in electrons moving from one surface to another. Most people have experimented with this form of charging an object, either rubbing a balloon on a jumper to make it cling or by shuffling their feet over a carpeted surface to build up an electrical charge to shock everyone. Friction is useful for charging insulators, which are materials that aren't good conductors. Conduction, on the other hand, is used to charge things that are good conductors, such a metal. A charged object is touched to the conductive material, and some of the charge, whether it is positive or negative, will be transferred. The final way to charge an object is by induction, and is again best for conductive materials. The uncharged conductive material is grounded on a neutrally charged material, and the charged object is filled near it. The charge will flow between the two objects, and the uncharged conductor will develop an opposite charge to the original charged object. There are two types of electrical charge, positive and negative, commonly carried by protons and electrons respectively. Like charges repel each other, and unlike charges attack each other. In ordinary matter, negative charge is carried by electrons and positive charge is carried by the protons in the nuclei of atoms. Types of charging. Charging means gaining or losing electrons. Matters can be charged with three ways: charging by contact, charging by friction, and charging by induction. Over 2,500 years ago, Thales of Miletus, a Greek philosopher, noticed something unusual when he rubbed a piece of amber with a piece of fur. He noticed that after contact with the fur, the amber attracted objects such as feathers and pieces of straw. Since then, scientists have learned that neutral objects can become charged through direct contact in several different ways. Two common methods of charging by contact are charging by friction and charging by induction. Charging by contact. There are equal numbers of electrons and protons in a neutral matter. If something charges this balance, we can say it is charged. First is we have charging by friction. When you rub one material to another, they are charged by friction. Material losing electron is positively charged, and material gaining electron is negatively charged. Amount of gained and lost electron is equal to each other. In other words, we can say the charges of the system are conserved. When you rub glass rod to a silk, glass lost electron and positively charged, and silk gained electron charged and B is negatively charged, there is no contact, they are charged only by induction. Conductors versus insulators. The behavior of a charged material depends on its ability to allow charges to flow to it. A material that permits charges to flow freely within it is a good electrical conductor. A good conducting material will allow charges to be distributed evenly on its surface. Metals are usually good conductors of electricity. In contrast to conductors, insulators are materials that hinder the free flow charges within it. If charge is transferred to an insulator, the excess charge will remain at the original location of charging. This means that charge is seldom distributed evenly across the surface of an insulator. Some examples of insulators are glass, porcelain, plastic, and rubber. That is it for today's lesson. Please don't forget